Good morning, everybody. Okay, you'll start to order these times in the afternoon from earliest to latest. Yuzuki uses number cards to make fractions equivalent to 1/2. What fractions can she make? And here are some shapes. Can you sort them into this Carroll diagram? Regular, irregular, quadrilateral, not quadrilateral. Okay, pause the video. Off you go, please. Welcome back, everybody. Okay, when we are ordering anything, if the units are different, it is difficult to do. So we've got some of these in 24-hour clock, some of them in 12-hour clock, some of them in fractions, and some of them written like this. So I'm going to put them all in 24-hour clock. So 16:55. 3:10 in the afternoon is 15:10. 4:30 is 16:30. And 10 to 4 is 15:50. Now they are all written the same way. And you could have done that anyway. But now they are all written the same way. I can order them from earliest to latest. So 15:10, 15:50, 16:30, 16:55. What fractions can Yuzuki make? She can make 3/6 is equivalent. I've times the 1 by 3 and the 2 by 3. Or she could have 6/12. I've times the 1 by 6 and the 2 by 6. And looking at these shapes, regular means all of the sides are the same length. Irregular means they are not. Quadrilateral means 4 sides. Not quadrilateral means not 4 sides. So, A is irregular, quadrilateral. B is regular, all of the sides are the same length, but it is not a quadrilateral. So it is, where are we? Regular, not quadrilateral. B. C, all of the sides are different lengths, and it is not a quadrilateral. So it is irregular, not quadrilateral. D, all of the sides are the same length, so it is regular, but it is not a quadrilateral. E, the sides are not the same length, so it is irregular, and it is not a quadrilateral. And F, all of the sides are the same length, and it is a quadrilateral, so it is a regular quadrilateral. I hope you got those answers right. Okay, we are looking at area today. The perimeter of a shape is the number of squares, the distance around the outside of the shape. So if I was to calculate the perimeter of these shapes, it would be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. So the perimeter of that shape would be 18 squares. The perimeter of this shape, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14 squares around the outside of this shape. And the perimeter of this one, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Okay, so as we have learnt in the last 2 lessons, the perimeter is the distance around the outside of a shape. The area is the number of squares that the shape takes up. So, to count the area of these shapes, I look at how many squares are coloured in. Let me see. Shape A has an area of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 squares. Shape B has an area of 1, 2, 3, 4, 5, 6, 7 squares. Shape C has an area of, there's a quick way to calculate this. If I do 1, 2, 3, 4 times 1, 2, 3, 4, that square would be 16, minus this one in the corner is 15. So that was my quick way, but I could also count them. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15 squares. Okay, so the shape with the largest area is C. The shape with the smallest area is B. Now, your first sheet today, you are just calculating the area of different shapes. And all you need to do is count the squares shaded in. However, there is a challenge, which is some problem solving. Here is an example of a problem solving. Esme is discussing the torn rectangle below. She says no matter how long, so we know how wide this rectangle is. The width is 1, 2, 3, 4 centimetres. But the length could be any length because that could stop there, or we don't know because it's ripped, it could go on one more or another one. So we don't know how long this rectangle is. Okay, we know how wide it is. Now Esme says no matter how long the rectangle is, it could only have an area that is an even number. Is Esme correct? Okay, well it's a rectangle, so we would find the area just like in our arrays by multiplying 4, the width, by the length. So if the length was 5 centimetres and the width was 4 centimetres, we know the area would be 20 centimetres. Okay, squared. If the length was 6 centimetres, it would be 4 times 6, which would be 24 centimetres squared. Okay, so we calculate the area by multiplying the length and the width. We know that of a rectangle, we know that because that's the same as our work on arrays when we are doing multiplication. Now, Esme says, no matter how long it is, so whatever this number is here, it can only have an even number. Okay, so here 5 is an odd number. When I have timesed 4 by 5, which is an odd number, the answer is even. Now, when it is 6, 4 times 6 is 24, which is also an even number. Let me see what it would be if it was 7 centimetres. 4 times 7 is 28 centimetres squared. If the length was 8 centimetres, 4 times 8 is 32 centimetres squared. All of these are even. So Esme is correct. No matter what this number is here, the area of this rectangle is always even. Why is Esme correct? Well, because she is timesing this number by 4. And all of the numbers in the 4 times table are even. But I would be happy with this for you to prove it by doing 3 examples. Okay, so first of all, you are just counting area. Okay, just counting the squares to show the area. Then you can go on to some problem solving. If you are calculating the area of a square or a rectangle, to find the area, you multiply the short side by the long side. So 2 centimetres times 6 centimetres, the area of this rectangle would be 12 centimetres squared, just like when we do arrays to show multiplications. Okay, well done Year 4, have a lovely day.